welcome to the class. The first thing you need to do is you need to go to a+students.com to the website. You need to select math as your subject, and then you need to select your grade. You're studying in grade 8. Okay. The topic for today is data and graph. Is data and graphs. We will see how to interpret graph. Okay. And the chapter number is, I'll just give you the chapter. Okay, the chapter number is 24. It is chapter 24. And the lesson number is 8. Okay, and the name of the lesson is Create and Interpret line plots with fractions in it. Because in the last lesson we did with whole numbers, right? So today we'll see with fractions. Okay, the first thing first, let's see what a fraction exactly is. Okay, so welcome everyone. Let's see what fractions are. That would be usually used over here. Okay, in the number plotting. So if I pick up a circle, okay, and if we are looking at what fractions are, right? Before moving ahead, we look at what fractions, basically what we would need to consider over here. Let's make 4 quarters, right? 4 quarters means we are breaking up the circle in 4 parts. Okay, so once the circle is broken down into all these parts, I'll start labeling. Okay, if I need to take this only, that means this is 1 out of 4, right? This is 1 out of 4. That means it can also be written as 0.25. 1 over 4 is 0.25, right? I'll just reduce this so that we can reuse this. Okay, if we have this, okay, I'll just make another copy, and we say now in the next one, if we have 2 regions which are shaded, okay, if this region and this region is shaded, that means this total shading is 2 out of 4, which can also be written as 1 upon 2, and or it can be written as half, 0.50. That means 2 regions are shaded in this case. Okay, if we look at the third option, and the third option can say, what will be the third option? If 3 regions are shaded, right? So what we can say is, if out of these regions, if 3 were shaded, this 3 would mean 3 out of 4 are shaded, or 0.75. These decimals and these fractions are equivalent numbers, right? So we need to remember these values first. 1 upon 4 is less than 2 upon 4 because the numerator is greater. Similarly, 3 upon 4 is the greatest fraction out of these 3 fractions. Okay, so if we can relate these fractions, then it would be very easy for us to break a number. Okay, one can be broken down into 4 segments. Okay, let's begin with the first question. Let's see what they're asking us. Just a minute, please. Okay. The first question we have is, let this be question number 1. Okay, let's paste it down. Okay, use the corrected line plot to answer the question below. This is question number 1. The weight of gift packages are given, right? So what we can see is the On the horizontal axis, it says pounds over here, right? That means the weight is given. The weight is in pounds. That means there was one package that was 3 pounds of weight. Three, after three, we can see how many gaps. From 3 to 4, it's broken down into 4 segments, right? The first segment, second gap, third gap, and fourth gap. That means 3 1 upon 4, 3 2 upon 4, and 3 3 upon 4. 1 upon 4 can also be written as 3 whole 2 upon 4 for comparison, right? So the question they're asking us is, what fraction of the packages weighed more than 3 but less than 3/4 of the pound? 3 and 3/4 of the pounds, right? Okay. Let's find all the columns that show values greater than 3 but less than 3 and 3/4. So let's try to find 3. So can we say that this is 3 and this is 3 whole 3 upon 4, right? So let's count the boxes, okay? There is one x in threes. There's only one x in threes, right? So we can write 1 over here. 3 1 upon 4, 3 and 1 quarter, 0. 3 and 1 half would be 1 box, 1 cross again, right? And 3 and 3/4 of 3/4 quarters would be 2 crosses over here, right? This is the total we can find, right? What are the total number of crosses in the line plot? 4. We can count them. 1 2 3 4 5 6 7 8 and 9, because we need to give what fraction of the packages. Whenever we need to create the fraction, that means out of the total. Okay, the total are 9, right? And what we had to find was weight more than 3. It cannot be 3. Anything greater than 3 and less than 3. So if I would consider this is 3, right? We cannot consider this. This is 3/4 over here. We cannot consider this because it is less than this and greater than this, right? Greater than 3 and less than 3/4. So there is only one which we can find, that is in the middle over here, right? That is between 3 and 3 whole 3/4 quarters, right? That means there is only one gift package which has a weight between 3 and 3 upon 4. So we write the answer for the fraction would be the total is at the bottom, and this is our required, whatever we require. So we can say the total number of x's were 9, and how many packages were in the weight between 3 and 3.75? There was only one package that was between this, okay? So we can say 1/9 of the packages are, or they have the weight between 3 and 3.75. Okay, let's try another question. Okay, let's see what else do we have. If we would, okay, I'll just copy the next. Let's try to redo this. Okay, question number 2, let's try a similar question. Okay, if we have this question, let's see. Question number 2 states that use the corrected line plot to answer the following questions. It's still talking about the weight of the gift packages, right? 1 minute, please. If I have, do I have? Yes. But they're asking a different question in this case. What they're asking us, the weight 3, for 3 pounds, there was one package. 3.5, there was one package. 3.75, there were two packages. 4.25, 4 and 1 quarter, that was 3 packages. 4.5, one package. 4 and 3/4, one package, right? But the question changes. What they're asking, if you stack all the packages that weighed exactly, they're saying it should weigh exactly three and three quarters, right? So how many packages we have with three and three quarters? There were two packages, right? Right. So the question changes over here, and they are saying, how much will the stack of these packages weigh in all? So we know that there were two packages having the weight of three and three quarters, right? So we need to find the total weight. What we can do is we can simplify the mixed number. We can change the mixed number, and we know how to change the mixed number. 3 whole 3 upon 4 can be written as 3 multiplied by 4 plus the numerator divided by 4, right? 3 times 4 is 12. 12 plus 3 is 15 upon 4, right? So in place of 2 whole 3 upon 4, we can also write 15 upon 4, right? And in multiplication, we know that the numerators are always multiplied with the numerator, and the denominator is multiplied with the denominator. Or we can write this as 2 multiplied by 15 is divided by 4. So what we can say is 2 times 1, 2 times 2 is 4, 2 times 1. That means our answer comes out to be 15 upon 2, which can be changed into a decimal number, 15, or the fraction or a mixed number. 2 stays out. 2 times 7 is 14. When we subtract, we are left with one remainder. That means 15 upon 2 can be written as 7 whole 1 upon 2, right? But you need to write the unit as well. You need to write the weight. That means the weight of the parcels, which were exactly 3 and 3 quarters. There were two parcels, right? So when we multiply 3 and 3 quarters by 2, the answer comes out to be 7.5 pounds. Okay. What we are in this question, what we are doing is we are changing the mixed number into an improper fraction. Then we multiply. Then we change the improper fraction back into a mixed number, right? And we are also assessing the data at the same time. Okay, so let's move on to the next question. Let's see what they're asking us in question number 3. Okay, the question number 3 is similar, but they're asking us to find a different value. Okay, just a minute, please. Okay, they are saying in question number 3, what they're saying is, if this was the question given, they have changed the question. The statement, the diagram is the same, but our requirement is different now. Okay. What they're saying is use the corrected line plot to answer the questions. It's still talking about weight. The weight is in pounds. What was the total weight of all the packages combined, right? So what we need to do is we need to find the total weight of the entire set of packages, right? So we can say there was 3 kilograms, there was one package, right? For 3 kilograms, there was only one package. Agreed? That means if for 3 kilograms there was one package, we can say this was 1. We can say 3 multiplied by 1. That comes out to be 3 pounds, right? So we write 3. We are adding them together on the corner, right? Then 3 1/4, there was none. But 3.5 also had one package. That means 3.5 had a one package that stays as 3.5. Or in decimals, we can say 3.5. So we can say 3.5. Okay. For the next one, 3 3/4, there were two packages, which we already did in the previous part. We found the weight, right? That means 3 3/4 with two packages came out to be 7.5 pounds. So we add 7.5. There was no package with 4 kilogram, right? 4 1/4, there were three packages. So we write 4, 1/4 is multiplied by 3. Agreed? So what we can say is, when we multiply 4 multiplied by 3 plus 1/4 multiplied by 3. 4 multiplied by 3 is, what is 4 multiplied by 3? That is 12. And this is 3/4. 3/4 can also be written as 0.75. Therefore, the total comes out to be 12.75, right? For these three packages over here. So this comes out to be, this comes out to be 12.75. Okay, I'll explain it to you, the numbers which do not have any decimals next to it, what we'll do with them, right? Then we look at another package that is 4.5 kilograms, and there was a single package. So that means the weight stays as 4.5. Okay, and the last one, that is 3/4 multiplied by 1. That means 4.75 when multiplied by 1 would be 4.75 pounds, because this was still a single package. So we write this as 4.75. Whenever we need to add numbers with different decimal places, what we do is we try to give them all the same decimal places. Okay, so we put double zeros over here, 0, 0, and 0. Okay, so when we add all these numbers together, what can we say? What can we say over here when we're adding all those numbers together? See, the 10th place of the units. This would be 0 plus 0 plus 0, 5, 5 plus 0 and 5. This is 10. We carry 1 over here. 1 plus 5 is 6, 11, 18. 18 plus 5 is 23, right? And 23 plus 7 is 30. So let's confirm 1 plus 5 plus 5 plus 7 plus 5 plus 7. That would be 30. So we keep the 0 over here and we carry the 3. Okay. 3 plus 3 plus 3 plus 7 plus 2 plus 4 plus 4. Right? So it comes out to be 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 7 is 16, 16 plus 2 is 18, 18 plus 4 is 22, 22 plus 4 is 26. We carry the 2 to the tens. 2 plus 1 is, right? So that means the total weight, we need to give our answer. The total weight is 36 pounds for all the parcels, right? So what they are doing is they are giving us the same question and they're changing the requirements. Okay, so we're getting to see how a single question can have different options on it, right? Let's try another question. Question number 4. I hope we agree on this. Okay, let's see question number 4. Let me just go up. Okay, so in question number 4, it says, let me just copy the question. What do we need to find? Trisha, just move to places. Okay, we need to complete the line plot in this question. Okay, first we'll do the line plot and then we will try to find more options through it. Okay, So it's question number 4. It says this. I'll just rewrite question number 4 over here. Okay. So in question number 4, what they are telling us, Trisha just moved to a new city. She made a list of places to visit in the city. For each place, she listed the distance and it's from her, right, place. Let's see how we can complete this. We need to use the data to complete the line plot, right? So what we can see over here is we are talking about the distance that is in miles, right? So we draw a horizontal axis, right? And on the horizontal axis, we would consider the distance, right? The distance is in miles. Okay, this is the distance from home. You give the heading distance from home, right? The line plot heading is distance. We are finding the distance from home. The important thing we need to see is what is the breakup? What should we label on the line plot, right? So when we see the miles, we can see a 2, we can see 1.5, and we can see a 1. Agreed? These are the only 3 distances we can see. Agreed? So what we do is we just need to mark these 3 points. 1, 1.5, and 2. We do not need any other distance, right? Because it's not a requirement. It's not there as a part of the question, okay? So let's see. Library was how many miles away? It was 2 miles. We make an X at library because it was. The zoo itself was 2 miles away. So what we know is now, up till now, there are 2 destinations which are 2 miles away from the home. Science center was still also 2 miles away. Okay. Bookstore was 1.5, 1 2/4, right? And the aquarium was 1 mile away from the home. Okay. So this is the line plot. Okay, we've completed the line plot. We made the line plot. So from the line plot, we can get the information how many places are there at particular distance from the house. Okay. So let's see if this question will continue. Okay. Okay. For this question will continue, and they are saying, okay, use the line plot to find, I would say question number 4, part, this would be part A. Let's label this as the first part of the question, and let's do it as the second part of the question, okay? For B, use the corrected line plot to answer the questions below. The distance from home, it's exactly the same line plot we read. What fraction of the places, they're asking what fraction of the places are more than 1 mile but less than 2 miles. It has to be more than 1, right? It has to be more than 1 but less than 2. So how many places were there? There was a single place that was greater than 1.1 mile but less than 2 miles. That is one place. But we need to give the answer in fraction. So the answer would be are required. The required is the question upon the total. What are the total places? How many places were there as total? 2, 3, 4, and 5. That means the total would be 5 options. Out of these 5 options, there was only one location that was further than 1 mile but less than 2 miles. That means there is only one out of 5 places. Okay. So we leave our answer as they are, as we are asked in the question. If they ask for the fraction, we leave it in fraction. If they ask for a decimal, then we change it, the question into a decimal. Okay. Let's see the next part, what they're asking us in the next part. Same question continued. And they are saying, just a minute, please. I'll just copy this. Okay. The second part, the continuation of the question says, okay, part C. That is the continuation, part C of the same question. Use the corrected line plot to answer the following questions. The distance from home was already given to us. If Trisha visits each place in exactly, that is exactly 2 miles from home. There were 3 places which were exactly 2 miles from home. How many total miles? They're asking how many total miles will she travel in all? Okay, they have given one more information. Only include the distance from home to the place. Do not include the distance back, because if she's home and she's going to the first place we had was if she's going to the library, then she comes back home also, right? Then she goes to the zoo, she again travels 2 miles and she comes back. Then she goes to science center and she comes back. But what they are asking us in the question is, do not include her coming back, only the distance that she is traveling if she's going to those places, right? So the distance should be 2 miles was 3 places, right? The distance into the number of locations. The distance was 2 miles into how many locations were there for 2 miles? That were 3 locations. That means she traveled 6 miles to the places that are exactly 2 miles from home, right? We need to, it could be less than 2 miles, it could be greater than 2 miles, or it could be exactly. So we need to follow the question very carefully. If it says exactly, then we just do exactly. Okay, moving on further with the same question, let's see, okay, if what is the requirement in the next part of the question. In the next part of the question, what they are saying is, using the same, okay, line plot, let's use the same line plot and let's try to find. Okay. What they are asking us in this part is, okay, very similar to the previous examples that we did. Now they want to know the total. In the fourth part of this question, the continuation, use the corrected line plot to answer the following questions. If Trisha visits each place, she's going to all 5 places. How many total miles will she travel in all? And we still have the same requirement that we need to ignore her coming back. Okay, do not include the distance back. So the first one, there was one place with 1 mile, agreed? Plus the second one, there was one location with 1.5 miles, agreed? And the last one was 1, 2, and 3. We already found the answer in the last part, right? There were 3 locations with 2 miles each. They were 2 miles away from the house, right? So 1 into 1 would be 1 mile, plus 1 into 1.5 is 1.5, plus 3 into 6, 3 into 2 was 6. So when we add them together, 6 plus 1 is 7, 7 plus 1 is 8, and 0.5. That means total miles traveled by Trisha would be 8.5 miles. Okay, that's the total distance we have traveled by her. Agreed? Okay, let's try another question. Question number 5. Okay, let's do question number 5. And let's see what we are asked to do over here. In question number 5, let me just copy the question, because these questions are all in a continuation, right? We do the first one, then we'll do the next one, and so on. Okay, this is question number 5. I'll just put it over here. And this is question number 5. Let's look at the parts. This is part A. Use a corrected line plot to answer the given question. The amount of glitter used, they're telling us how much glitter would be used. For 2.5, 2.5, that is 1 glitter box used. 2 5 upon 6, 1 glitter box used. 3 containers, 2 boxes used. 3 upon 8, right? That is 2 boxes used over here, right? So what fraction, the question says, what fraction of the paper chains use more than this containers, but less than 3 1 upon 4, right? So what we need to see is we need to find the position 2 and 3 quarters, right? So what is 2 and 3 quarters? This position. It has to be greater than this, but it has to be less than 1 4 3 1 upon 4, right? So in between this range, how many we can find containers? Within this range, we only have 2 containers, right? Agreed? So they are, so how we do the fractions? We do the fraction as we are required answer upon the total, right? So our required was 2 upon the total. What was the total? 1 2 3 4 5 and 6. So 2 upon 6 is our final answer. But since this fraction can be simplified, it can be written as 1 upon 3 as well, right? So we can say 1/3 of the paper chains, 1/3 of the paper chains weighed between this given range, right? The weight was between the given range. So that's what we need to consider. Okay. Now let's move on and let's see the continuation of the question. Okay, let's complete this and then we'll do a few questions from the test as well, right? So I'll just continue with the second part. Same question, part B. In part B, they are saying a continuation, a second. This is part B. Use the corrected graph line plot to do this. If you combine all the glitter from they're saying, if you combine all the glitter from the paper chain that use exactly 3 3/8 of the container, right? How much glitter will you have in the as a complete? So what they're saying is we need to find all those which use, right? So how many were there which use exactly this much? How many containers were there which use exactly 3/8? There were 2 containers which used exactly, sorry, which used exactly this, right? So what should be the total? That means 3 whole 3 upon 8, and there were 2 containers, right? The quantity used was 2, right? So what we can say is, the other way to multiply is we multiply this by this and this by this, right? So we can say 2 multiplied by 3 is 6. 2 multiplied by 3 is 6 upon 8, right? But 6 upon 8 can be further simplified. This becomes 6 upon 8 would become 3 over 4, right? So we can say 6 whole 3 upon 4 containers were used, which had exactly 3 upon 8, right? Okay, let's try the next part of this question. Any questions till now? If you have any questions, we can always do that first. Okay, if there are questions, let me know. Thank you. The next part of the question says, what was the total? I'll just copy it on the screen. Okay, total weight, I think they're asking. Let's read this. Okay, if this was the continuation, this is part number 3, part C. The same diagram given, and they're saying what was the total amount of glitter used. Okay, that means we need to find the total. That means 2 1/2 is 1. That means 2 1/2 is multiplied by 1 plus 2 5 upon 8. Sorry, 2 5 out of 8, 2 whole 5 upon 8. There was a single container plus 3. There were 2 containers, right? That would mean 3 is multiplied by 2. And for the last part of the question, we already solved in the previous example, right? This was, we already did in the previous example. This was 3 whole 3 upon 8 times 2. We can always refer to this answer from the previous example. This was this answer over here. Okay, so 2 into 1 upon 2 would be 2 1 upon 2, right? Plus 2 whole 5 upon 8 plus 6, and the last one was plus, we already solved this in the previous part. This would be 6 whole 3 upon 4, right? We know that 5 divided by 8 is 0.625. We can either do it by decimals by converting, so we can simply put action. This is 2.5 plus 2.625 plus 6 plus 6.75. And when we add these numbers together, the answer will come out to be, let's use a calculator over here, 2.625 plus 6 plus 6.75. We're just using it because it's a lot of decimals over here, right? So that comes out to be, we can always do it manually, 875, right? So that means the total weight comes out to be 17.875 for the containers use. Okay, this is the number of containers that had been used in order to use the glitter. Okay, so let's move on to, let's do test, a question from the test. Let's see what do we have in the test. Okay, I'll start off from the test over here. The first question from the test, there are how many questions? Let's see. There are only 10 questions, and we'll do a few. You try the remaining. Okay, I'll just copy the question over here. Okay, this is the first question that we have. I'll just reduce the size so that it's readable. I'll increase the size so that it's readable for us. I'll rewrite this. This was 8 whole 1 over 2, and this was 7 whole 1 over 2. Okay, so we have this as option A and we have this as option B. The question says use the corrected line plot First question from the test. Distance from the home is given 1, 1.5, and 2. Trisha visits each place. How many total miles will she travel in all? We need to find total distance. That means 1 mile was 1 plus there's 1.5 miles one location. And how many locations with 2 miles? There were 3 locations, right? So 1 plus 1.5 plus 6. So 6 plus 1.5 is 7.5 and 7.51 is 8.5, which is also written as 8 and 1/2. Right? I just did the first question for you so that you'll have an understanding what we need to do. The next question, I'll wait for you to answer, okay? So in this case, option A is the correct answer. Let's go to the website and let's click on the option A. It shows it's correct, okay? So the next question is here for you. I'll wait for you to answer this. And if there are any questions, let me know. I'll explain it in between, okay? Okay, the next question, question number 2, states that it's a very similar question which we did earlier. Okay, and the statement says this. Okay, this is question number 2 from the test. If you combine the glitter from the paper chain that use exactly 3 whole 3/8 containers, how much glitter will you have in total? They're saying how many containers were there? These many containers. I'll just highlight this. There were 2 containers using 3 and 3 out of 8, 3 whole 3/8 containers, right? Can you give me the answer? I'll wait for your answer. So that means if 3 whole 3/8 was used, 2 containers were used, we simply need to, what do we need to do? Can anyone help me out with that? Yes, we need to multiply them together. So this is 3 whole 3/8, right? This is 3 whole 3/8. And there were 2 containers. So what we need to do is 2 is multiplied by 3 whole 3/8. Help me out with the answer. I'm waiting. We know how we can multiply a mixed number directly by a whole number. The hint is, I'll give you a hint. The whole number is multiplied by the whole number in the mixed number and by only by the numerator. It does not multiply with the denominator. So it should be, see, when we look at both the options, option A and option B, we do not even have to worry about what the fraction would be, because option A says 6 whole 3/4 containers and option B says 7 whole 3/4 containers, right? But when we multiply, 2 is multiplied by 3 and this multiply. So the first one, 2 is multiplied by 3, we already get 6 as the answer. We cannot have 7 as the whole number, right? Yes, option A is the correct option, right? Because we already know that it cannot be 7. Then 2 multiplied by 3 was 6/8, which can be further simplified, 6 whole 3/4, right? So our confirmation point is this number, because we can do the 6, we cannot do the 7, because 7 is not there. Okay, let's try one more. Let's see one more question. Okay, we have, okay, it says use the corrected plot line graph. Let's just copy this. So we have question number 3. I'll just copy this over here. Okay, and question number 3 over here says, from the test, the remaining questions which would be left, you need to complete it on your own. Okay, please do that. These are the weights given in pounds of the Give packages. What fraction of the packages? It says fraction. Weight more than 3 but less than this. It should be more than 3 but less than this, right? More than this but less than this. So how many packages were there in total? First, always count the total. I'm highlighting this so that you can count. Yes, there are 9 packages on the total. So if there are 9 packages and we have these two options, right? So what way we can differentiate is we cannot have 7 in the 9. We cannot have 7 in the denominator, right? What should we have in the denominator? Can anyone answer? Yes. Because there are 9 total packages, the denominator has to be 9. And there is only one option that has 9. If there would have been a third option saying 2 upon 9, then we need to look into it, right? And how many packages were there? Between this range, more than 3 and less than 3/4? Yes, there was only one package. That means 1 upon 9, that is option B. Yes, your answer is correct. Option 2 is the correct answer, right? And the few more questions are left. Please do try as per your homework. Finish the test. If there are any problems, just go through the video again, step by step, and do the test so that you may have a better revision, right? Thank you so much. Thank you for your time. Best of luck. Take